All right, so again, April the 18th, 2022, and we're about to start circle theorem. And I start by saying that in circle theorem, we look at 9 of the established geometric relationship theorems among the angles formed by intersecting chords and or radii inside of a circle. So there are about 9 circle theorems that we have to learn. And circle theorems is about the relationship that is formed when chords and radii or diameter intersect within a circle. Some basic things that we should know. So we should know that a chord is any straight line that is drawn across a circle connecting 2 points on the circumference. So any line that you draw across a circle that touches the circumference at 2 points, any straight line that is drawn across a circle that touches the circumference at 2 points is called a chord, and that the chord divides the circle into segments. All right, what else? The diameter is a special type of chord. So the diameter is also a chord. It's a special type of chord. The diameter divides the circle into 2 equal halves, and a half of a circle is called a semicircle. All right, so the diameter is a special type of chord in that the diameter must pass through the center of the circle. So a line is not a diameter unless it passes through the center of a circle. It must pass through the center of the circle, and the diameter divides the circle into 2 equal halves, and a half of a circle is called a semicircle. Guys, the radius is any straight line that is drawn from the center of the circle to any point on the circumference. The radius is half of the diameter, and the plural of radius is radii. So that brings us now to our first circle theorem. Now, the first circle theorem, 1 says angles in the same segments are equal. The first circle theorem says angle in the same segment are equal. All right, so the diagram here is showing us to some extent how do we identify angles in the same segment. So first of all, here we have a line AB. Now, the line AB is called a chord. The line AB is called a chord, and the chord divides the circle into segments. So down here is a segment, that's a minor segment, and all of up here is a segment. That is the major segment. So the line AE is the chord, and the chord divides the circle into segments. So again, AE is the chord, and the chord divides the circle into segments. Now, the angle at B, C, and D, they're all equal, and they're called angles in the same segment. Guys, let us see how we identify angles in the same segment. So first of all of these angles start at A, go up to the circumference, and then come back down toward E. The angle at C also starts at A, up to the circumference in the same segment, and then back down toward E. Now the angle at D also starts at A, up to the circumference at D, and then come back down toward E. So what we are seeing is that all 3 angles have their start and end at opposite ends of the chord AE. And the angle itself is formed at the circumference in the same segment. So B, C, and D, they are all at the circumference in the same segment. And they all have the same starting point and the same ending point on the circumference. They all start at A and they all end at E. And the angles B, C, and D are formed at the circumference in the same segment. These angles are called angles in the same segment, and angles in the same segment are equal. Now, the second diagram is very similar. PT is the chord. The chord divides the circle into segments. You'll notice that the angle S, R, and Q, they all start at T and end at P. And the angle themselves, they are formed at the circumference in the same segment. These angles are equal. They are called angles in the same segment. All right, so let's turn the page. All right, so these are observations. Our observations are one, angles in the same segment have the same starting point and the same ending point on the circumference. So angles in the same segment have the same starting point and the same ending point on the circumference. And the vertex of the angles is at the circumference in the same segment. Those are observations. Now, the second circle theorem we're going to learn is angles in the same segment. Sorry, angles in a semicircle. Now, circle theorem number 2 says the inscribed angle in a semicircle is equal to 90 degrees. The inscribed angle in a semicircle is equal to 90 degrees. Or you could say angles in a semicircle is equal to 90 degrees. All right, so let me tell you how you get angle in a semicircle. You're going to have a circle, and now passing through the center is the diameter. Passing through the center, you have a straight line passing through the center that touches the circumference at 2 points. This is my diameter. Now, if I start an angle at one end of the diameter up to the circumference and come back to the other end of the diameter, that angle is called the angle in a semicircle, and it must be equal to 90 degrees. So let's see how we identify the angle in a semicircle. First, you must have a diameter. How do I know I have a diameter? It is a straight line that passes through the center of the circle that touches the circumference at 2 points. Guys, if I have the diameter and I start an angle from one end of the diameter, go up to the circumference, and then come back down to the other end of the diameter, the angle that is formed in the semicircle, that angle must be equal to 90 degrees, and it is called the angle in a semicircle. So the diameter AC divides the circle into 2 halves. A half of a circle is a semicircle, and the angle in a semicircle must be equal to 90 degrees. All right, so let's call this P. There's no letter there, so let's call it P. PR, diameter, TU, diameter, the angle at S and the angle at P, they are formed at the circumference in a semicircle, and the angle that is formed at the circumference of a semicircle is called angle in a semicircle, and it must be equal to 90 degrees. So angle in a semicircle starts at one end of the diameter, go up to the circumference, and then come back down to the other end of the diameter. So the angle starts and ends on opposite ends of the diameter. The vertex of the angle is on the circumference. The angle in a semicircle is equal to 90 degrees. Stay with me. And number 3, before we go and look at a question. All right, so circle theorem number 3 says the angle at the center is 2 times the angle at the circumference. The angle at the center is equal to 2 times the angle at the circumference. So let us see how we identify angle at the center and angle at the circumference. This is the center of the circle. This is a chord. Let's say this is my chord AB. Now, if I draw a line from A to the center of the what? Circle, and then come back down to the other end of the chord, down to B, this angle is called angle at the center. Now, if I start at A up to the circumference and then come back down to B, this angle is called angle at the circumference. So let's call this C. So both angles start and end on the same point on the circumference. So they both start at A and they both end at B. One goes to the center of the circle, the other goes to the circumference. The angle that goes to the center is called the angle at the center. The angle that goes at the circumference is called the angle at the circumference. Whatever this angle is 2 times that angle. The angle at the center is equal to 2 times the angle at the circumference. So circle theorem number 3 is the angle at the center is equal to 2 times the angle at the circumference. Circle theorem number 2, and the angle in a semicircle is equal to 90 degrees. How do we identify it? Start at one end of the diameter, up to the circumference, back down to the other end of the diameter. This angle must be 90 degrees. Start at one end of the diameter to the circumference, back to the other end of the diameter. This angle must be equal to 90 degrees. It is called angle in a semicircle. And the third one, before we look at a question, the third, which is the first one we looked at, angles in the same segment. They start at the same point on the circumference, end at the same point of the circumference, and the angles which are equal, the angles at B, C, and D, they are equal and they are called angles in the same segment. So angles in the same segment are equal. The angle in a semicircle is equal to 90 degrees. And 3, the angle at the center is equal to 2 times the angle at the circumference. All right, so let's see what the next page brings. So this is the observation for the last one. Both the angle at the center and the angle at the circumference start and end at the same point on the circumference. The vertex of one angle is the circumference, and the vertex of the other, the vertex of one angle is the center of the circle, and the vertex of the other is the circumference. All right, so those are the first 3 circle theorem.